Data is a raw facts, figures and statistics, whereas information is a processed data. Each node contains two parts. One is data part and one more is address part. Data structure that are directly operated upon by machine level instructions are known as primitive data structure. When they come on arrays, all the elements of same data type, but when they come on list, the elements may be homogeneous or it may be heterogeneous. Welcome back to One and All. Myself, Vasanta, lecturer in Computer Science, Vidhyaashram, Pre-University College, Temple of Excellence, Mysuru. Today, we are going to start with the first session of data structure. The total weightage in the annual exam on this chapter, total 14 marks in the annual exam. In part A, one question you will get for 1 mark. In part C, there you will get one more question for 3 marks. And in part D, you will get 2 questions for 5 marks. Then total weightage of this chapter is 14 marks in the annual exam. Whereas in part D, you will get 2 questions. Usually from this chapter, you will get the questions regarding algorithm as well as operations for 5 marks. Whereas on today's class, you will come to know regarding what do you mean by data structure, data representation and how to classify a data structure, that is classification of data structure. Then before starting this data structure, first if you know what do you mean by data, then easily you can able to understand what do you mean by data structure. Data is a raw facts, figures and statistics. It's a raw material. Data is a raw facts, figures and statistics. If I want to prepare a sambar, for example, on that case, whatever ingredients we are taking, that can be called as data. After preparing sambar, that sambar can be called as information. It means that data is a raw facts, figures and statistics. For example, if I am going to write 123, then it is a data. Because here it will not going to give any specific meaning, is it? No. Bus number, Rix number, phone number. It is a raw material. For example, if I am going to write register number equals 123, then it is a information because information having specific meaning. In this case, now we can identify that register number is 123. It means that data is a raw facts, figures and statistics, whereas information is a processed data. One more example I am going to give you. For example, if I want to construct a building, on that whichever raw materials, whatever raw materials we are taking, that raw materials can be called as data. After constructing the building, that building can be called as information. Whereas now you come to know what do you mean by data. Then what do you mean by this data structure? Data structure is a specialized format for storing, organizing, managing the data in a computer memory. What do you mean by that? In systematic manner, how data are arranged, how it is stored, where it is stored, how to access that. Regarding that, mainly this data structure deals. I am going to give one more example. For example, consider you have the books. You are going to keep all the books in different places. For example, one book you are going to keep it on bedroom and one book on kitchen and one book on hall. On that time, it is not possible to access that book easily whenever you want. Is it no? If the books are kept in different position in different areas, then easily we cannot able to access. If you are going to keep all your books, especially on your bedroom, especially on your cupboard, then easily you can able to access. Is it no? In the same way, in computer also, if data are arranged in systematic manner, in systematic way, then easily we can able to access the data. That is nothing but data structure is a specialized format. It is a specialized format for storing, organizing, managing the data in a computer memory. Whereas data is a collection of raw facts, figures and statistics. In order to process the data should be organized in a particular way. In a systematic manner, the data has to be arranged. The data structure should provide to manage large amount of data efficiently. If we have data structure, then efficiently, in systematic manner, I can able to manage all the data. Whereas data structure mainly deals on how data are stored, where it is stored, how to create, how to manage. Regarding that, mainly it will deals. Whereas data structure organize a collection of data items in the appropriate form so that it improves the efficiency of storage and processing. If I kept all the books in systematic manner, then easily I can able to access. The processing is also very easy here. In the same way, this data structure helps to manage large amount of data efficiently. Data structure is a specialized format for storing data efficiently. Mainly, it helps to manage the data, store the data in systematic manner. Data representation, where computer memory is used to store the data which is required for processing. It means that memory is needed to store both input data as well as output data. This process is known as data representation. How data are stored in the memory. Regarding that, mainly it will deals when the come on data structure is a method of storing data in the memory. How data are stored in the memory. Then the study of data structure mainly deals with the logical structure of the data, then implementation as well as analysis of the data. It means that data structure mainly deals with how exactly the data is stored, where exactly it is stored, how to access the data. Regarding that, mainly it will deals. Next, we will discuss the classification of data structure. Whereas data structure, already you come to know that it is a specialized format for storing, managing, organizing the data in a computer memory. But when you come on the types of data structure, there are two types. One is primitive data structure and one more is non-primitive data structure. Then what do you mean by this primitive data structure? Primitive data structure are very simple by nature and it concentrates on only one data item. It will concentrate on only one data item. It is very simple by nature and here we does not require any translator. Whatever data we are written here we does not require any translator. The instructions are directly executed by machine level instructions here. That is primitive data structure. Whereas already I told you this is very simple. It concentrates on only few amount of data and with that here simple with that here whatever instructions we have written that is directly executed by machine level instructions. When we come on the classification of primitive data structure, one is integer, character, float as well as pointer. These are the classification of primitive data structure. Then what do you mean by this non-primitive data structure? Whereas non-primitive data structure is derived from primitive data structure only, but it is very complex by nature and with that it will concentrate on group of data items. Whereas here it concentrates on only on single data items, whereas here it concentrates on group of data items and it is derived from primitive only, but it is very complex. When we come on the classification of non-primitive data structure, under that we have arrays, list as well as files. There are three classifications under non-primitive, that is arrays, list as well as files. Then what do you mean by this array? Whereas array is a collection of homogeneous elements. Then what do you mean by this homogeneous elements? Homogeneous elements means all the elements of same data type stored under same name. For example, consider int a of 10. If I am going to write, then it is an array and here it contains totally 10 elements. All the 10 elements of integer data type only stored by the same name A. Whereas array is a collection of homogeneous elements. Homogeneous means same data type. For example, if I am going to write float b of 100, then totally 100 elements are there. All the 100 elements stored with the same data type, float by the same name A here. It means that it concentrates on group of elements, all the elements of type same data type here, array. Then when we come on types of array, there are three types under array: one-dimensional array, two-dimensional array, as well as multi-dimensional array. But when we come on one-dimensional array, here the array contains only one subscript. If you observe here, only one subscript we have, only one element, but the subscript here only one here we have. Total elements 10, here total elements are 100 here. Whereas single dimensional array means in the array that contains only one subscript, then it can be called as single dimensional array, where it may be row wise or it may be in column wise. But when you come on two dimensional array, it contains two subscript. For example, int a of 10 is to 10. Here, if you observe here, we have two subscript, first one and then second subscript. Whereas in two-dimensional array, we have two subscript. The first subscript represents the total number of rows and the second subscript represents the total number of columns in that array. For example, if I am going to write the first one, 10 represents totally 10 rows are there. Whereas here we have 10. Then here it represents totally 10 columns are there. One more example. For example, int a of 2 is to 2. Then 2 rows and 2 columns. 2 rows as well as 2 columns here we have. Here we have first value, second value, third value, fourth value. Now is it clear? Whereas two-dimensional array means it is a collection of homogeneous elements only, but it contains two subscript. And the last one is multi-dimensional array. The multi-dimensional array, here if you have more than two subscript, then it can be called as multi-dimensional array. For example, consider int a of 2 is to 2 is to 2. Then it can be called as multi-dimensional array. Here it contains more than 2. This is the first subscript, this is the second subscript. More than 2 subscript if you have, then it can be called as multi-dimensional array. Whereas array is a collection of homogeneous elements. One dimensional, only one subscript, two subscript, more than 2 subscript. Next, when we come on the classification of non-primitive data structure, under that the next one is list. Then what do you mean by this list? Whereas list is a collection of elements only. But here the elements may be homogeneous elements or it may be heterogeneous elements. Whereas when they come on arrays, all the elements of same data type. But when they come on list, the elements may be homogeneous or it may be heterogeneous. Elements may be homogeneous or heterogeneous. But here the collection of elements only. When they come on list, there are two types. One is linear and one more is non-linear. The name itself suggesting that linear means all the elements are arranged one after the another without any break. If elements are arranged one after the another without any break, then we used to call it as it's a linear data structure. All the elements are arranged one after the another in a continuous memory location. All the elements are arranged. Then when they come on non-linear, the name itself suggesting non-linear. It means that elements are arranged randomly. There is no any continuous memory locations here. Then it can be called as non-linear data structure. Whereas under linear, already I told you one after the another, all the elements are arranged. Elements may be homogeneous or it may be heterogeneous. But when they come on the classification of linear, once again it is classified into 3 types. One is stack, queue and one more is linked list. Then what do you mean by this stack? Stack is a collection of elements only, but insertion of elements as well as removal of elements will take place at the same position. Consider we have one container here. On this container, insertion of elements as well as removal of elements will take place at the same position. That position can be called as top of the stack. Whereas here, elements may be homogeneous or it may be heterogeneous. The main thing is insertion of elements as well as removal of elements will take place at the same position. Whereas array is a collection of elements. Here we are not bothered about on which place we are inserting, where we are deleting, that doesn't matter. Only thing, elements are homogeneous. But when they come on stack, stack is also collection of elements, but insertion and deletion has to be take place at the same position. That position can be called as top of the stack. And the next one we have queue, whereas on queue is also collection of elements, but insertion as well as deletion will take place at different position. Consider one queue. Here we have the position elements 0, 1, 2, 3, 0, 1, 2, 3. The insertion of elements as well as removal of elements will take place at different position. The place where we are inserting, that place can be called as rear, and the place where we are removing an element, that can be called as front. Whereas in queue, it is a collection of elements, but insertion of elements will take place at rear position and deletion of elements will take place at front position. But when we come on linked list is a collection of nodes we used to say. Collection of nodes. Here each node contains two parts. One is data part and one more is address part. What do you mean by this data part? Whereas the data part contains the actual information, whereas the address part contains the address of the next node. Whereas here collection of elements, insertion and deletion will take place at the same position. Here also collection of elements, but insertion as well as deletion will take place at different position. Whereas the linked list is a collection of nodes. Whereas nodes is nothing but it contains two parts. One is data part and one more is address part. In the data part, it contains the actual information, whereas the address part contains address of the next node. Next, when we come on non-linear, there the name itself already I told you, the elements are arranged randomly. Further, the examples are tree as well as graph is the example. For 1 marks, you may going to get the question, give the example for primitive data structure. There it may be integer, character, float you have to write. Otherwise, in the exam, they may want to ask, give the example for non-primitive. Then array, list as well as files you have to mention. Otherwise, give the example or types of arrays, one-dimensional array, two-dimensional array, multi-dimensional array. Otherwise, in the exam, you may want to get the question, list, give the example for linear data structure. Under linear, stack, queue and linked list. Otherwise, you may want to give the example for non-linear data structure. For that, tree as well as graph are the example. Whereas non-linear means elements are arranged randomly. But here also it contains group of elements. And the next one, we have files. Files is a basic storage unit in a computer system. It is a basic storage unit. Here we can able to store the data, files, everything we can able to store here. This is the structure of data structure. How data are there. How data, different types of data structure, primitive, non-primitive. Next, we'll discuss about primitive data structure. Already I told you, primitive data structure, it is very simple. It concentrates on only one item. Here, whatever instructions we have, that directly executed by machine level instruction. We does not require any translator here. It concentrates on only one item. It is very simple by nature. The same thing, data structure that are directly operated upon by machine level instructions are known as primitive data structure. Example, integer, float as well as characters are the example for primitive data structure. Next, when we come on the operation, this question you are going to get for 3 marks. Write the operation or explain the operations on primitive data structure. Then which are the operations I can able to perform? First, I can create one data structure, that is create. That is used to create a new data structure. For example, int x. I can able to create one data structure here. Then destroy. The second operation is destroy. The name itself suggesting that whichever data structure we have created, that can be destroyed, that can be deleted here. 4 major operations in primitive data structure we can able to perform. The first one is create. I can create a new data structure. Then destroy. Here, whichever data structure we have created, that can be destroyed, that can be removed, that can be deleted. And the next operation is select operation. On the data structure, whichever data we have, that can be accessed here, select. It is used to access the data item within the data structure. Accessing is about taking the data. I can able to create one data structure. Whichever data structure I created, that I can destroy. On that data structure, whichever data I want, I can select only that data. That is, select operation I can able to perform. Then update. Update is used to change data of a data structure. For example, here I am having some data. I want to make some changes on that data. Then I can able to perform update operation. Because in primitive data structure, we can able to perform only 4 operations. One is create, destroy, select and update. Next class, we will explain regarding the operations on arrays, how to perform array, how to create an array, which are the operations we can able to perform on non-primitive data structure as well as arrays. What do you mean by queue? Then stack, how to write the algorithm, how to write the concept, especially in 2-dimensional array as well as in 1-dimensional array, how the data will stored in the memory, everything you will come to know in the next session. Thank you for all of you.